was good, thanks. Yours? It was nice. I was able to go pick up my motorcycle from the shop and I got to go ride for a little bit. That one. What's that? That one. That one. The sticker that's been on my computer the entire school year. Aprilia?
I didn't even know that was brand.
Italian? Sport bike. Sport tourer. Anyway, so today we're going to start talking about general angles and radian measures, and this is where trig and all of the angle stuff that we've all gone through switches into what we'll start talking about, what's called the unit circle. And it's kind of where everything starts to blend together of why everything maths the way it maths and so on. But what we're going to do to start with this, we start talking about angles in what they're called terminal positions and stuff like that. So, for example, what we talk about here is this thing called an angle in standard position. An angle in standard position. What happens is, excuse me, what happens is when we plot our angles and look at stuff, we're always going to have what's called an initial side and a terminal side. Your initial side always starts at 0, and we start 0 degrees on the x-axis of the first quadrant area on the right-hand side of that. So that's always going to be where your angles start, your initial spot. And then whether they are positive or negative tells you what direction you're going to go. So if we have a positive angle, we work counterclockwise. If we have a negative angle, we work clockwise. So, excuse me, we have positive angles that go this way, and then negative go that way. And what we do is we talk about what quadrant an angle's terminal side lies in. So if I say we have a 110 degree angle, 110 degrees, well, here's 90, 180, 270, 360. Your angles start at 0, comes back here, and then we can say that's 110. One thing I want you guys to start getting used to doing, though, is that when you see that you have an angle, wherever it winds up, I always want you to write down how far it is from an x-axis. Okay? So this one's 110 degrees up. How far does it have to go to get to here? 70. Bless you. Okay? Excuse me. So I'm getting us accustomed to something that we'll talk about. I don't know if we get to it today or not, but kind of foreshadowing. Another idea. Let's say you've got negative 130. Again, you start at 0. Negative 130, you got to remember that you got to come back into, that would be quadrant 3, I believe. How many degrees does it have to get back up then? We always measure it, it's 50 degrees off, so you just say it's 50 degrees off. Yes, because the negative here is about what they call direction. It's just direction. So it's just direction. Excuse me. Yeah, no, I've got the cough from it. No, and that was the other thing. Just sweeping out the garage with all the junk that was in there. All the dust and all the dirt and everything out. What's that? Can't hear you. The what? Yes, the bike. Yes. Anyway, so what happens if you have this? Exactly. So what happens here is that you can go multiple revolutions in these types of things. You just gotta count. So if you think about it, excuse me, here's 360. After 360, 540 would be 1.5, correct? So this is less than 1.5, so this still has to come back into second quadrant. How far is it off of the x-axis? 30. Okay. Remember, as you're going around, you have 0, 180, 360. And then if you add another to it, you're at 540. Sure. Think of it this way. If I do this, if I subtract out 360 from the 510, excuse me, of 150 degrees, right? So isn't that just plotting 150 degrees with an extra loop? Really all that we're looking at. Hi! I'm glad you showed up. We were worried. Thanks, Joe. Anyway, so this idea here, this 510 and 150, these two angles are what you call coterminal. These are coterminal angles. Coterminal angles are just angles that share the same, I'm drawing a blank. Terminal side, sorry. Coterminal angles are angles that share the same terminal side. Think of this. They share the same end spot, if you will. They have the same terminal side. Okay. So when you're looking at it, if you have 150 degrees, if you add 360 to it, you wind up back at 150 degrees. You add another 360 to it, you'll be back at 150 degrees. So every time you go around, you're going to be in the same position. Okay. So coterminal angles, you can have positive coterminal angles and you can have negative coterminal angles. So if I wanted a negative version of landing at 150, if I wanted a negative version of landing at 150, that means I'd start here, I'd go negative 180, and then I'd have to add up how much? Another 30. So this would be at negative 210. So negative 210, I'm just going the other direction. I wind up in the same spot. Okay? I just went a different way. So if you have 150, you wind up there. You're 30 degrees off of the 180 line. If I go 210, negative 210, I'm just going the other direction, past negative 180, up 30 degrees. So I'm at the same spot. So angles that have the same position are just called coterminal. So you have 150, negative 210, and 510. These are all coterminal. They're all coterminal. Excuse me. Try another one real quick. Let's say we have, which one do you want to do? Negative? Sure. Let's say you've got negative 60. I'm going to do a positive and a negative coterminal angle of negative 60 degrees. Okay. So first of all, if I go negative 60 degrees, that means I'm starting at 0 and I move to the fourth quadrant down 60 degrees. Oops. Okay. All right with that? Now, a positive angle means I have to start at 0 and work counterclockwise to be 60 degrees off of the x-axis. Well, if I go full around, it'd be 360, so I just back it out 60 degrees. So what would the positive version be? 300, good. So the positiveness is coming around here at 300 degrees. Okay. Now, what would be another negative version of negative 60? If I wanted to go negative and wind up at the same spot, I'd go 360 and another 60, which is okay. So you get the idea of you're just going around, around, and around. And to be honest with you, all you're doing is adding and subtracting 360. Yes. I know. Well, hopefully you pick up on this. Positive and negative coterminal angles, all you're doing is adding and subtracting 360. Okay. That's all it is. Don't overthink it. That's terrible. Now, one thing that does happen from time to time is sometimes your initial angle that they give you is beyond one revolution. If you're beyond one revolution, if you have to go positive or negative, you always bring it into one revolution. So if I do, let's say, 600 degrees, I'm going to plot 600 degrees, and then I want to put out a positive and a negative coterminal angle. 600 degrees is, well, if you think about it, 600 degrees is one revolution. There's 360. If I go halfway, it'd be 540. And then this would just be another 60 degrees after that. So we go 360, 540, 60. And there's 600 degrees. Okay. How far did I write that off of the x-axis? 60 degrees off. Okay. So if you think about it, that was more than one revolution. Another positive to that would be just to do this. Subtract 360. If I subtract 360 from that, I'm going to get, what? 240. So there's my positive coterminal angle. I just start at 0, work my way around to 240. Okay with that? If I did my negative coterminal angle, it means I have to start at 0 and go negative. If I go negative, well, I'd be 60 degrees off from negative 180, so it would be negative 120. In other words, I'm subtracting 360 again, and I get negative 120. So here is my positive, here's my negative. You're basically adding and subtracting a revolution to get to it. Whenever you're looking for coterminals, you want them all to be within one revolution if you start beyond one revolution. It's just like, it's like etiquette. Like pinkies up that kind of thing. I figured you would be okay with me having that. All right. Excuse me. Which gets us to our fun stuff. You're gonna have a lot of circles with this stuff. Now, you guys are okay with knowing that this is 0, 90, 180, 270, and 360. Correct? You okay with that? Now, if we get real fancy, and I'm cheating, yes. Thank you. I just did that by hand. You're welcome. Well, yeah, you used your hand. So I wasn't wrong. Now, if I wanted to change this up a little bit, and I say that this has a radius of 1, what's the circumference if the radius is 1? 2 pi. Okay. So circumference is when you're dealing with it's 2 pi r. Everybody okay with that? Yes. Now, if I say that my radius stays at 1, that means to get all the way around the circle would be 2 pi. You all right with that? So if I start at 0 and I go all the way around, I end at 2 pi. I know, this is where it goes to though. What's half of 2 pi? Pi. What's half of a pi? If I add a pi to a half pi, what do I get? 1.5 pies. Okay. Now, if you break it down even further, if I want to go and say, if I want to say that this is 45 degrees, isn't that half of a half? What's half of a half? A quarter. Therefore, if I went this direction, what's halfway between 180 and 90? If I add 45 to 90 degrees, what do you get? 135. If I add a half, if I add a quarter to a half, what do I get? 3/4. So 3 pi over 4. If I go this way. Now, if I go in terms of a whole, isn't that the same thing as 4/4? So it would be 5/4 pi. If I add 45 degrees to 180, it's 225. Here I'm going. And if I go the other direction here, you don't have to memorize anything. Now, one of the things you should be able to pick up on here is, aren't these two directly across from one another? So what's going to be, if I add 180 to 135, what do you get? 315. Because they're one part away. Now, if I add 4/4 to 3/4, what do you get? 7/4. 7 pi over 4. Again, the reason why this works, if you start looking at it in terms of quarters, here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, which is the whole thing. All right? You all right with that? Now, go to another angle. If I take 90 degrees and I cut it in a third, it's 30, isn't it? It's 30. Okay. It's 30. What is a third of a half? A sixth. Now, if I go up by 30 degrees from there, what do I wind up at? 60. What's 30 degrees from 60? 90. 30 degrees from 90, 120. 30 degrees from 120, 150. 30 degrees from 150, 180. 30 degrees from 180, 210. 210, 240. 240, 270. What's this one going to be? 300, and then 330. Now, what's going on here is you might be able to tell right away, what are the two special triangles that are building this whole thing out? 30, 60, 90, and the 45, 45, 90. If you go up by 30s, you're going up by a sixth every time. So you have 0/6, 1/6, 2/6. Well, what's 2/6? 1/3. It's pi over 3. So 1/6, 2/6, 3/6, which is a half. 4/6, which is 2/3. 4/6, 5/6, 6 sixths, 7 sixths. I can't say the 6. I got fake teeth. This hurts. 7 sixths, 8 sixths, which is 4/3. 9 sixths, 10 sixths, which is 5 pi over 3. 10 sixths, and 11 sixths. Well, we don't. You're welcome.
Actually, I shouldn't say that out loud. You do cut those in half again later, but you do that in 3 pounds. There's this thing called half angle double angle formulas. So you'll work with 15 degrees, 7 degrees, and you'll worry about that later.
So, but yeah, this is how that unit circle, which is what this is called, the unit circle is derived. You don't need to, and the idea here is, guys, that there is absolutely no reason ever to have to memorize this. Because if you can start at 0 and go all the way around to 2 pi, cut it in half, cut it in half, cut it in half, cut it in half, add quarters, cut it in a third, add thirds, it works itself through. Obviously, this is the first time you've really, I've shown you a little bit of this already, but I haven't gone into why all of it was showing up like that. It is where all of trigonometry is going to be built out of. What's that? There's no reason to memorize it. It's very difficult to go about. And that's the thing. Just remember, it's 1 6, 2 6, 3 6. 45 is half of 90, add a quarter. You just count by quarters. That's really all you have to know. 1 6, 2 6, 3 6, and build out. All right? There are many, there have been a lot of times in Algebra 2 that people do want to memorize this, but they spend so much time memorizing it, they don't understand how it works. And by understanding how it works and how things get placed into it, it's much easier and quicker. Okay? And we'll get to why we need to know how to do all that stuff later on. But today what we're going to do is talk about conversions. How to convert from radians to degrees, how to go from degrees to radians. So here's what we've got. No, there's not a button here on the calculator for this. But this is where that rad button comes from. So radians, degrees. In order to go from degrees to radians, degrees don't have pi in them. Radians do. So to rewrite a degree into radians, you take your degree, slap a pi next to it, and divide it by 180. And then you simplify the fraction. So if I have 110 over 180 with a pi in it, I simplify the fraction. Well, this just, zeros drop, and you get 11 pi over 18. And that's 110 in terms of radians. Okay. Same deal goes for if you're working the other direction. If I'm going from negative pi over 9, and I want to go from radians to degrees, degrees don't have radians. Radians have pi in the numerator, so it means you have to have pi in the denominator for it to cancel out. So you multiply this by 180 over pi. What's pi over pi? 1. What's 180 divided by negative 9? 20, but it'll be negative 20. And there's your there's your degrees. Okay. Now, this whole idea of converting radians and degrees is very quick, but I will suggest that when it asks you to do something in radians, keep it within radians. The more accustomed you get to working with terms of pi, the easier it becomes. For example, if I want you to plot, and I want you to figure out a coterminal, a positive and a negative coterminal angle in terms of pi. Let's say we have 11 pi over 4. I want to plot that, and I want to figure out what are some positive and negative coterminal angles with that. Now, you've heard me say this before, that mixed numbers are stupid. They are, except for right here. This is the only time they make any sense. True, but not. Anyway, how many times does 4 go into 11? Twice, and how many are left over? So that tells me it's 2 3/4 pi. So there's 2 pi. Where's 3/4 then? What quadrant do I land in? Remember, it's 3 pi over 4. Is that more than halfway? Because remember, your half is here. So it's got to go here. How far is that off of the x-axis? How much? Well, it's okay, but I'm not dealing in degrees. I don't know what that is because I have a pi. Remember, when you have 4s, that's all. Those are all. You know what he says? 45-degree angles. So if I'm in the second quadrant and I'm 45 degrees off the bottom, which means I am pi over 4 off the bottom. Okay. In order for me to get to a whole pi, I'd have to add a 4th. Because right now I'm at 3/4. That's where I'm getting at. Yes, ma'am. No, because remember, this is pi. That's how it works. So you get 2 pi. So let's see here. That means you guys already said that my positive, if I subtract 2 pi, my positive coterminal would be 3 pi over 4. Okay. There's my positive. My negative then would be, well, here's negative pi plus a quarter. So if I'm going more than 1 pi, or I go another quarter negative past the whole, well, negative 4/4, negative 5/4. It's subtle, but it works. It just takes a little bit of time to get used to seeing. It just takes a little bit of time to get used to. You were saying about, since it was 2 pi, is it 2 times around? Remember, 2 pi is 1 full revolution. Okay. You get all the way around on that one. Because you'll see stuff that'll ask you, where do you land if you've got 17 pi over 4? Or you have to start counting, like, what's 17 pi? How many times do you land on things like that? Okay. Oh, radians and degrees are so much fun. Yeah. Excuse me. Let's see what else do they have. I don't want to go too fast. I've already gone too fast with that whole unit circle thing. You want me to show it one more time? Explain it more. No, here. Okay, real fast. It's okay. Now, and I know this is weird to start seeing. Now, again, just a real quick build here. If you start in degrees, you start at 0, and you go all the way around, you end up at 360. What's half of 360? What's half of that? If I add 180 to 90, I get, okay. If I cut 90 in half, I get 45. If I add 180 to that, I get 225. Because these are 180 apart. Okay. If I add 45 to 90, I get 135, which means over here it was 315. That little trick of adding 180 only works with the 45s. Okay. Because they're always the same amount off the x-axis. They're always 45 degrees off. So they work out that way. Now, if you go back just to this one to start, if we know that this is 0 and then this is 2 pi, what's half of 2? What's half of that? If I add 1 to that, I get. Okay. So far, so good? Yes. Okay. What's half of a half? Fourth. And now I'm just going to count by a fourth. 1/4, 2/4, 3/4. 4/4, 5/4, 6/4, 7/4. And then here would be 8/4. Okay. 45s are nice because you're just counting, you're just going up a quarter, 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 all the way around. Okay. Now, take the 90 degree, cut it a third. What's a third of 90? 30. Okay. So if I go a third of 90, and if I go up 30 degrees, add 30 degrees, add 30 degrees, guys, and all I'm doing is adding 30 degrees all the way around. 180, 210, 240, 270, 300, 330, 360. Yes, it does. I totally agree with you on that. Thank you. So now we know that 90 degrees is pi over 2. 30 degrees is 1/3 of that. So 1/3 of a half is a sixth. So this is 1/6. So this is pi over 6. This is 2/6. Oops. Pi over 3. 3/6. 4/6. 5/6. 6/6. 7/6. 8/6. 8/6. 9/6. 10/6. And 11/6. Because that gets me to 12/6. So every one of those, every 30, 60, 90, 1/6, 1/6, 1/6. You're just adding a sixth on your way around. Okay? Plus, if you think about it this way, what's 360 divided by 30? It's 12, so you should have 1, 2, 3, 4. I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You should have 12 of the sixths going around. See how it goes? It's like I said before, it's weird. And it takes a minute to understand how it goes. But once you figure this out, once we start getting into this more, probably tomorrow or Wednesday, this value here and this value here are the same distance off, which means they have the same reference angle. Okay, and there's a lot of things that happen there. All right, also comes with the idea, you guys might want to write this down. I know we've talked about this. Remember how we talked about positives and negatives? And it just goes with the same idea as quadrants as you've done in the past. That doesn't change. And we'll get into all the particulars as we get through this more and more and more and more. Just to start, this is kind of where we're at. And then really the only other parts that are in here for today is with some quick quick conversion stuff, is that they talk about what's called areas and arc lengths and areas of sectors. You guys did this last year in geometry, where you did arc length. You did arc length was central angle over 360 times 2 pi r, I think is what we did. Well, if you look at it, what's 2 over 360? Pi over, so this is pi over 180. So this is the same thing as angle times pi over 180. Wasn't that how you convert to radians? Yes, you're right. I did. I walked in and I started doing all the unit circle stuff. So arc length last year when you did it, you guys were already converting stuff into radians. You just didn't know you were doing it. So this value here is what is the conversion from degrees to radians multiplied by the radius. And this is exactly what you did last year. You just didn't realize it. So if you have a radius of 4 and a central and an angle of 40 degrees, what you did is you did 40 over 180, slap a pi next to it, multiply it by the radius. Okay. And you would just simplify stuff out. This is exactly what you did last year for arc length. You simplified to, what is that, 9, so this is 8 pi over 9. That would be your arc length. Okay. And go back up, sorry. So this idea of what they do here is this value of arc length. I should put this as an angle. Theta is your central angle in radians. See, that's why you guys did that conversion for it last year. So when they put it out as this this arc length, they call it S, is your radius times theta, but theta is in terms of radians. So all I have to do is convert your degrees to radians and basically multiply it by the radius. So if they give you a radian measure to start with, you just multiply by the radius and line right away. Whereas if you do the area of the sector, you guys, if you remember that was the ratio, it was your central angle over 360 times pi r squared. Well, it's the same basic idea, but they're converting it to radians right off the bat. So they have it as 1/2 radius squared times theta. And this is, again, this theta value is your angle in radians. So you do that quick conversion. Okay. Central angle times pi divided by 180, and there's your radians. And we go from there. Right. It takes a couple days to get used to this nomenclature, if you will. It's fun. It's good fun. So let's do this. This is pretty cool. They seem crazy, but they're not.
That's what I try to tell you.
And we'll do a little bit more of this again tomorrow. Keep working on it. It takes a little bit of time to get used to the whole idea of radians and go from there. I believe I have that already. I think the PDF file's already up. I think I put that up last week.